everyone, and welcome to video 3 of complex numbers in polar form. In this video we're talking about multiplication, division, and powers of complex numbers. So let's take a look at multiplication and division first. I like these formulas because they're kind of easy to remember. If I'm multiplying complex numbers, what I do is multiply the two moduli and I add the two arguments. Okay, and it stays in complex form. It's just you multiply the two moduli and you add the two arguments. For division, you divide the two moduli and you subtract the two arguments. And it's as simple as that. So let's take a look at an example. Okay, so I have z1 equals 2 times cosine pi over 4 plus I sine pi over 4. And z2 equals 5 cosine pi over 3 plus I sine pi over 3. So for multiplying, if I do z1 times z2, all I need to do is 2 times 5 and then times the cosine of pi over 4 plus pi over 3 plus I sine pi over 4 plus pi over 3. And then I just need to simplify this. 2 times 5 is 10. Now pi over 4 and pi over 3. This is 3 pi over 12. And this is 4 pi over 12. If I add those, I get 7 pi over 12. So this is the cosine of 7 pi over 12 plus I sine of 7 pi over 12. Okay, and that is my answer to the multiplication. For division, if I did z1 divided by z2, I would do 2 divided by 5 times the cosine of pi over 4 minus pi over 3 plus I sine pi over 4 minus pi over 3. Okay, and now the 2/5 can't really be simplified, but what I can do is simplify this subtraction. So I have 2/5 times the cosine, and 3 pi over 12 minus 4 pi over 12 is negative pi over 12 plus I sine of negative pi over 12. Now you may remember the even odd identities tell me that this negative sign doesn't make a difference, so I can just erase that. But on the sign, it would make a difference. So I'm just going to use my even odd properties to take this negative and move it to the front of the sign. So this becomes, let me just move up, 2/5 times the cosine of pi over 12 minus I sine pi over 12. And that was just my even odd identities. Okay, let's take a look at powers now. This is de Moivre's theorem. Okay, it's one of the things he's famous for. He's done a bunch of things, but this is one of them. And it's finding the power of a complex number. So when you're finding the power, it's just take the modulus to that power and then take the argument and multiply by the power. Now remember, your numbers need to be in complex form first. So notice my example problem is not in complex form, so I have to go through the steps to finding that first and then raise it to the 10th power. So for my r value, I have to do 1/2 squared plus 1/2 squared, and it's the square root of that. This is 1/4 plus 1/4, which is 2/4, also known as 1/2. So it's the square root of 1/2, which is square root of 2 over 2. Now for my theta, I know tangent of theta equals this divided by this. Now it's something divided by itself. That's just 1. Notice this is in quadrant 1. In quadrant 1, pi over 4 has a tangent of 1. So I found r and theta. So this is really, okay, z to the 10th, where z is square root 2 over 2 times the cosine of pi over 4 plus I sine pi over 4. Okay, so this is what I'm doing. So I have to raise this to the 10th power times the cosine of 10 times pi over 4. Let's just put brackets around this. Plus I sine of 10 times pi over 4. Okay, now the square root of 2 over 2. It's much easier to simplify this if I write the square root as a fraction. So the fractional exponent here is going to be 2 to the 1/2 power. And I can do 10 times 1/2 is just 5. So this is really 2 to the 5th power over 2 to the 10th power. And my laws of exponents say that this is just going to be 1 over 2 to the 5th. Okay, and 2 to the 5th power comes out to be, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is 1 over 32. Okay, and then for my pi over 4 times 10, I can reduce this. This becomes a 2, and this becomes a 5. So it is the cosine of 5 pi over 2 plus I sine of 5 pi over 2. And that is it. Now, if I wanted to, I could turn this back into rectangular form simply by finding the cosine at 5 pi over 2 and the sine at 5 pi over 2. So I'll show you those steps as well, because generally, if we're given something in rectangular form, like this, unless they specifically say write your final answer in polar form, we should change it back to rectangular form at the end. So 5 pi over 2, let's take a look at where that would be. This is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So cosine is 0 and sine is 1. Okay, so this is going to be 0 plus I times 1. And it's 1 over 32 times that. Okay, which is 0 plus 1 over 32 times I. So I can write it like this, or I can write it like this, but that's basically what it is. So that's it for this part of the lesson. The last video is going to cover doing roots of these. So finding a square root, a cube root, or some other type of root. So come back for that.